There is a specific kind of silence that belongs only to the high desert of the Uinta Basin as twilight begins to settle over the mesa. It is not merely the absence of sound, but a heavy, physical presence, a quiet so profound that a person standing at the edge of the plateau can hear the wind rasping through the sagebrush hundreds of yards away. For generations, this stark landscape in eastern Utah has held an unsettling reputation, a place where the horizon seems to bend under the weight of unexplained phenomena and where the ground itself feels watchful. To the casual observer, the massive rock formation known simply as the Mesa appears to be nothing more than an ancient deposit of sandstone, shale, and fractured basalt, carved away by millions of years of wind and water. Yet, beneath this weathered facade lies a history that defies conventional geology. For decades, researchers, engineers, and independent scientists have brought sophisticated instruments to Skinwalker Ranch, attempting to quantify what sits behind the stories that have clung to these ridges for well over a century. They have recorded localized magnetic distortions that twist compass needles out of true alignment, sudden broad-spectrum radio frequency spikes that vanish as quickly as they appear, and unexplained aerial phenomena that seem to originate from or vanish directly into the cliff faces. For years, the investigation remained confined to the surface and the open skies above, treating the land as a stage upon which strange events occasionally played out. But as long-range monitoring equipment became more refined, the focus shifted downward. Aerial magnetometry, localized thermal scanning, and baseline acoustic monitoring began to paint a picture not of solid stone, but of structural complexity hidden deep within the earth. The surface, it seemed, was merely a lid covering something far more intricate. The decision to move from passive observation to direct physical exploration was not made lightly. Breaching a geological structure in a region known for volatile electromagnetic behavior carries immense technical and logistical challenges. Yet, as data accumulated from multiple independent field seasons, the evidence became impossible to ignore. The rock beneath the mesa contained significant structural voids, spaces where solid stone should logically exist. To stand at the base of that ridge with heavy drilling equipment idle in the dust is to experience a unique form of tension, a realization that humanity is about to cross a threshold that has remained undisturbed for centuries. The goal was not to disturb the land recklessly, but to carefully, methodically open a window into the dark, seeking answers to questions that have lingered in the silence of the Uinta Basin for generations. Every instrument was double-checked, every frequency monitor calibrated to baseline settings, and every safety protocol reviewed under the fading twilight. The researchers knew that once the stone was pierced, the physical baseline of the entire property might change forever, turning decades of theoretical discussion into an immediate, tangible reality. As the final light faded over the western ridges, the team gathered at the operations center to review their primary objectives, knowing that the morning would bring an unprecedented physical encounter with the hidden depths of the mesa. To understand why a team of seasoned field researchers would commit weeks of intensive labor to drilling into dense, unforgiving rock, one must look at the subterranean maps generated by months of non-invasive geophysical surveying. Before a single machine was transported onto the property, the land was subjected to an exhaustive array of scientific analyses designed to read the shadows hidden beneath the earth. High-resolution LIDAR sweeps mapped the microtopography of the mesa's surface, revealing subtle structural sagging and lineal fracturing that did not align with natural erosion patterns. Ground-penetrating radar units, dragged painstakingly across the rough terrain, sent high-frequency electromagnetic pulses deep into the substrata, measuring the time it took for those signals to bounce back from boundaries between different materials. What the operators saw on their digital displays was puzzling. Standard sedimentary and volcanic formations returned predictable, uniform cross-sections, layers of soil, sandstone, shale, and bedrock stacked in orderly horizontal bands. Beneath specific sectors of the mesa, however, the radar signals hit abrupt barriers before dropping into complete acoustic shadows. Seismic imaging, which measures how shockwaves travel through stone, confirmed the anomaly. Instead of passing uniformly through a solid geological mass, the waves slowed, reflected, and scattered as if striking a massive, isolated void. The data suggested the presence of a subterranean cavity situated beneath hundreds of feet of dense basalt and packed sandstone. This immediately sparked an intense, quiet debate among the geological consultants and field engineers on site. Was this simply a complex, natural lava tube or a dissolved limestone cavern system typical of certain desert regions? Or were they looking at something far less conventional, a space whose geometric boundaries appeared strangely defined for a natural cave system? As the surveys were repeated using different frequencies and calibration models, the anomaly remained fixed in space, refusing to disappear as a software glitch or environmental artifact. More unsettling was the discovery that the perimeter of this void seemed to be bordered by a dense, highly reflective barrier that absorbed or diverted electromagnetic energy, creating a sharp boundary between the known rock above and the mysterious darkness below. The team was no longer merely reading geological charts. They were looking at a subterranean puzzle that demanded a physical answer. They cross-referenced their findings with regional geological surveys spanning back 50 years, finding no record of natural cavern development at this depth or within this specific basalt strata. Every chart pointed to the exact same conclusion. An unnatural spatial discontinuity existed beneath the mesa, holding its breath in the cold dark, waiting for a light to be shown inside. Detailed structural cross-sections indicated that the void held a distinct orientation, running parallel to the natural fault lines of the basin yet displaying a subterranean ceiling that maintained a curiously consistent horizontal plane across several hundred feet of scanned length. Transitioning from digital models to physical action required extraordinary care and technical precision. The plan was to execute a controlled core drilling operation, creating a vertical borehole only a few inches in diameter through the outer shield of the mesa until reaching the void below. This approach allowed the team to sample the rock layers sequentially while minimizing any structural damage to the surrounding geology. On the morning the heavy drilling rig was powered up, the air at the site was filled with a taut, focused energy. The mechanical roar of the diamond-tipped bit biting into ancient basalt shattered the customary silence of the basin, sending vibrations through the boots of everyone standing near the platform. Foot by foot, the drill ground its way into the mountain, extracting continuous cylinders of rock that were immediately cataloged, measured, and stored in protective cases. For hours, the process moved forward with monotonous predictability until the bit reached the depth where the radar had predicted the top of the subterranean void. Without warning, the heavy hydraulic gauges on the drilling rig plummeted toward zero. The intense resistance of the dense basalt vanished in an instant, and the drill string dropped several inches freely into empty space. Simultaneously, the digital monitoring stations set up nearby registered a sudden, localized spike in broad-spectrum electromagnetic interference. Mobile communication links flickered, video telemetry screens glitched with harsh static, and baseline signal monitors registered a distinct shift in environmental pressure. It was the physical relief valve moment of the entire operation. The borehole had successfully pierced the roof of the hidden cavern. A steady, quiet hiss of air escaped from the top of the casing pipe as the pressure between the ancient chamber and the atmosphere outside equalized. The temperature of the air venting from the depth was surprisingly cool and carried an unusually crisp, dry quality, completely distinct from the warm desert wind blowing across the surface. Researchers stepped forward with portable gas analyzers and environmental sensors to verify that the air exiting the hole was safe for equipment deployment. Once cleared, the team prepared to lower a specialized, fiber-optic camera probe down the shaft, realizing that within moments, human eyes would see inside a space that had been sealed in pitch-black silence for an unfathomable period of time. Every hand on site was steady, yet every mind was acutely aware that the barrier between the surface world and the subterranean dark had officially been broken. Engineers adjusted the winch speed to a crawl, ensuring that the fragile optical unit would enter the void smoothly without striking the freshly cut edges of the rock casing, while data loggers noted the exact timestamp of the pressure equalization event. As the high-resolution optical probe began its slow descent into the borehole, the live video monitors on the surface captured the transition from the rough, spiraling grooves of the freshly drilled rock to a vast, open emptiness. The powerful LED light head mounted on the probe cut through the subterranean dark, casting long, shifting shadows across an environment that instantly defied easy categorization. The first images returned to the command trailers showed microparticulates suspended motionless in the air, shimmering softly like tiny metallic flecks caught in the artificial beam. As the camera was rotated 360 degrees on its motorized axis, the structural walls of the cavity came into focus. The rock faces were not the soft, rounded, water-carved surfaces typically found in natural solution caves, nor did they bear the sharp, jagged rubble heaps characteristic of a fresh tectonic collapse. Instead, the walls exhibited a strange, fractured uniform quality, featuring long, straight planar surfaces that intersected at consistent, almost calculated angles. The stone itself possessed a deep, iron-gray coloration, interspersed with thin, reflective veins of an unidentified mineral that caught the light with a cold, metallic luster. As the operator gently lowered the cable further into the cavern, the beam illuminated a floor covered in fine, powder-like sediment, undisturbed by water currents or wind. Yet, as the probe was panned toward the far western recess of the space, the telemetry feed suddenly began to degrade. Digital noise, green banding, and static swept across the high-definition monitor, obscuring the far end of the passage just as it seemed to bend deeper beneath the mesa. The signal did not cut out completely, but rather fluttered as if passing through a localized field of intense radio frequency distortion. On site, the engineering team attempted to recalibrate the signal transmission lines and reinforce the shielded cabling, but the video distortion remained confined specifically to that deeper section of the chamber. It became glaringly clear that the cavity was not merely an isolated underground room. It was part of an extended subterranean system, a passageway whose true dimensions stretched far beyond the original footprint identified by the ground-penetrating radar. The monitors flickered with an eerie consistency, offering tantalizing glimpses of geometric structures that faded back into static every time the camera attempted a closer focus. The team noted with quiet intrigue that the optical glare along the upper rock face seemed to follow a continuous horizontal band, suggesting a uniform layer of highly polished or vitrified material running along the cavern ceiling. With the physical doorway now open, the team turned its attention to gathering real-time atmospheric and physical measurements from within the subterranean void. The data returning from the deployed sensor package presented a series of environmental anomalies that challenged standard cave dynamics. Primary among these was the temperature distribution throughout the chamber. In a typical underground cave, the ambient temperature remains remarkably stable, reflecting the mean annual surface temperature of the surrounding region. However, thermal imaging cameras lowered into the mesa recorded distinct, highly localized pockets of extreme cold situated in open air, completely unattached to any solid surface or visible airflow source. These thermal sinks remained strangely stationary, failing to mix with or cool the surrounding air mass in a manner consistent with basic thermodynamics. Equally perplexing were the acoustic signatures recorded by ultra-sensitive hydrophones and low-frequency microphones suspended inside the shaft. The instruments picked up a continuous, rhythmic infrasound signature, a deep, low-frequency pulse hovering around 12 Hz, far below the threshold of human hearing, but physically felt as a subtle, vibrating pressure in the chest of those standing near the borehole on the surface. This exact frequency matched historical acoustic recordings captured at surface level during previous research projects on the ranch, suggesting that the mesa itself might be acting as a massive resonator or conduit for this subterranean energy. Systematically, the scientific staff worked through a process of elimination to rule out mundane sources. They checked regional seismic monitors to confirm that no minor geological shifts were occurring nearby. They verified that nearby oil and gas drilling operations were inactive, and they confirmed that no surface winds were forcing air down the casing pipe to create a resonance effect. The data refused to collapse into a conventional explanation. The physical environment inside the sealed cavern was behaving according to a set of physical variables that were active, dynamic, and stubbornly unique. The low pulse continued unabated, a rhythmic heartbeat emerging from the deep stone, humming through the digital recorders, and leaving the field team to ponder what mechanism could sustain such an energy signature without a clear power source. Further cross-checks with atmospheric pressure sensors confirmed that the void experienced slight, periodic pressure shifts every 40 minutes, as though the subterranean chamber were quietly breathing in rhythm with an undisclosed external or deep earth pump mechanism. While the optical and atmospheric data offered compelling clues, the physical material extracted during the core drilling process provided concrete, tangible evidence that could be analyzed under microscopic scrutinization. The core samples corresponding to the rock layers directly surrounding the upper perimeter of the underground void were taken immediately to an on-site portable laboratory for elemental and structural analysis. The results were startling. The transition layer between the standard sandstone matrix of the Mesa and the subterranean ceiling was composed of a dense, highly compacted composite material containing elevated levels of heavy metals, including iron, titanium, and unusual trace concentrations of rare earth elements. Metallurgical scanning revealed that these metallic grains were distributed with a degree of structural uniformity that is rarely encountered in natural sedimentary deposits. Furthermore, the material exhibited strong magnetic anisotropy, meaning it held a permanent, highly directional magnetic alignment that differed significantly from the ambient magnetic field of the surrounding Uinta Basin bedrock. When compared against baseline soil and rock samples collected across various sectors of Skinwalker Ranch during earlier field seasons, these subterranean core samples represented a distinct geological anomaly. Historical records from state mining archives were consulted to determine if any commercial excavation, exploratory shafting, or military tunneling had ever taken place on or near the property during the late 19th or 20th centuries. The records were unequivocal. No legal mining operations had ever been registered for this specific sector of the Mesa, nor were there any historical accounts of early settlers possessing the heavy industrial machinery required to penetrate hundreds of feet of solid basalt to construct an underground chamber of this scale. The physical composition of the shield surrounding the cavern presented a profound puzzle. A dense, highly conductive barrier embedded deep within a rural Utah desert, sitting quietly beneath the soil for an unknown duration of time. Chemical testing further confirmed that the bonding matrix between the metallic particulates resisted standard acid etching, indicating a physical durability that surpassed surrounding natural rock formations by a significant factor. Additional spectroscopic evaluations indicated that the crystalline structures within the core samples were aligned under extraordinary heat and directional pressure, conditions that do not align with the known geothermal history of the local Uinta formation. The discovery of a structured void deep within the Mesa does not exist in an intellectual vacuum. It resonates deeply with the long, rich human history of the Uinta Basin. For centuries before modern research teams arrived with radar units and core drills, the indigenous peoples of the region, most notably the Ute and Navajo tribes, viewed the land around Skinwalker Ranch with profound respect and deliberate caution. Tribal oral histories are filled with references to specific geographic features along the mesa, describing them as places where the ground itself was hollow and where unusual sounds, lights, and entities could emerge from the rock face. Elders passed down warnings that certain locations were not meant for human habitation, describing the land as a threshold between different realms or a resting place for forces that should not be disturbed. When European homesteaders began settling in the basin during the late 19th and early 20th centuries, they too began recording observations that matched the older traditions. Personal diaries and local newspaper archives from the era contain numerous accounts of ranchers hearing deep, rhythmic subterranean thumps coming from beneath the earth during quiet night hours, often accompanied by unexplained tremors that were localized to individual pastures rather than spreading across the valley as a true earthquake would. Cattle would occasionally vanish from secure pastures situated near the base of the mesa, leaving no tracks, blood, or physical evidence behind, leading early residents to speculate about hidden sinkholes, deep fissures, or treacherous subterranean caverns. By comparing these historic accounts with the modern geophysical data collected during the Unsealing project, a remarkable continuity emerges. The stories passed down through generations were not merely mythical fabrications or exaggerations of simple events. They were the observational records of human beings responding to a real, persistent physical anomaly anchored to this specific piece of ground. The ancient warnings and the modern sensor readings speak the exact same language: caution, awareness, and an acknowledgement that something fundamental remains hidden beneath the earth. Archival records from early 20th century geological surveys of eastern Utah also make passing mention of unusual subterranean air currents detected by early stone prospectors along the northern rim, though these observations were discarded at the time as irrelevant minor natural fissures. Standing at the edge of the borehole as the sun sinks below the horizon, the true significance of the unsealing operation becomes clear. The objective was never merely to drill a hole in the ground or produce a momentary sensation. It was to conduct a careful, disciplined inquiry into a place that has guarded its secrets for centuries. The unsealing of the underground cavern beneath the Mesa did not bring a simple, neat conclusion to the mysteries of Skinwalker Ranch. Instead, it opened a vast new horizon of scientific inquiry, replacing surface speculation with hard, physical data that poses even deeper questions. The structural geometry of the void, the cold thermal pockets that defy simple physics, the continuous low-frequency acoustic signature, and the metallic composition of the surrounding stone all point toward a complex system that modern science is only beginning to map. Before any human descent or expanded physical excavation can be considered, engineers and safety specialists must overcome significant technical hurdles, ensuring that the structural integrity of the mesa is preserved and that proper environmental controls are established to protect both the team and the land itself. Every step forward requires patience, precision, and an unyielding commitment to objective truth. The readings captured during this initial breach represent only the first chapter in understanding a structure that may extend far beyond the current reach of our instruments. What has been uncovered so far serves as a powerful reminder of the limits of human knowledge, demonstrating that even in an age of satellite mapping and advanced technology, there are still places on Earth where the unknown remains absolute and untouched. The work at Skinwalker Ranch continues not with boastful certainty, but with quiet discipline, patient observation, and a profound respect for the mysteries that still lie waiting in the dark beneath the ancient stone of the Uinta Basin. As night falls completely over the high desert, the instruments continue their silent watch, recording the slow, steady pulse of a world beneath our feet that is only now beginning to speak to those who listen closely